Hello friends, welcome to EPG Padasala. I am Dr. Karpagam Chinnamma from Chikana Government Arts and Science College, Tirupur. Today we are going to deal with a new printing technology, digital printing. Printing is a method of applying color to a textile substrate in a specific pattern or design. There are different methods used for printing and are quite varied from primitive methods like block printing to sophisticated automatic machinery. The journey has been from brushes, blocks, batiks to the rollers, screens and digital. Non-conventional printing is a new concept developed very recently. These kinds of printing methods include the usage of modern machinery and skilled labor. The most recent is digital printing on textiles. It provides a tool to the designer where uninhibited thinking for design creation is possible, which can be finally transferred onto the fabric. Digital printing is a technology that has gained reputation in the last couple of decades. The demand for digital textile printing for apparel and home furnishing is rapidly growing. After this session, you would have gained knowledge about digital printing and its methods. Be aware of the advantages and disadvantages of digital printing. Be acquainted with the future scope of digital printing. What is digital printing? Digital printing is a process of creating prints designed and generated from a computer as opposed to analog printing, which require printing screens. It's a non-contact method of substrate decoration which produces images, colors and patterns using computer-driven inkjet nozzles. The design is transferred directly from the monitor to the textile. The design to be printed sits in the computer in the form of digital data that can be converted repeatedly with or without any variation into a print. The print can be obtained by connecting computer to a printer. The RIP, that is raster image processor software, instructs the printer on when and how much drops is to be placed on the fabric to create the color design. The print design is created by proper positioning of drops. Unlike conventional printing, in digital printing, colorants are mixed on the fabric during the printing process. Inkjet printing gives the printer a very high degree of flexibility when compared to traditional screen printing. This technology offers quick changes in color and design. It is faster and cost-effective production. Further, it reduces waste and pollutants significantly. Digital printing processes, mainly based on inkjet systems, are making inroads into the textile printing sector, which is presently dominated by rotary screen printing. When compared to conventional printing, in case of digital printing, pattern location is more precise, efficiency is high, and production cost is low. Color shifting is easy, change of design is easy, and can be done in minutes. The speed is low, new pattern cost, waste and machine overhead are low. There is no limitation of design, high degree of ink purity, no thickeners is used, color and pigment usage is minimum. The elements of digital printing. The elements of digital printing are the substrate, pre and post treatments, ink print heads, fabric feeding system, or printer and software. Getting all this right is the key to success. Now let's look into the digital printing process. Designs can be created digitally with almost any graphic design software like Photoshop, CorelDRAW, or Illustrator. Alternatively, existing artwork or photographs can be scanned and then digitally manipulated to make the pattern. Usually, designs are created as a seamless pattern that is repeated across the fabric. You can also create a design that fills an entire yard without repeating. During the printing process, the fabric is fed through the printer using rollers and ink is applied to the surface in the form of thousands of tiny droplets. The fabric is then finished using heat or steam to cure the ink. Some ink also requires washing and then drying. The printing machine. Digital printing machine can be classified on the basis of the type of pass as follows. That is scan pass, and the second one is single pass. In the scanning head method, both the print head moves in the width direction as the fabric is gradually advanced. The other is line head printing, also called the single pass method, where the print heads are stationary and the fabric moves. By this method, the faster speeds have been achieved. Like in some machines, you have an array of fixed heads across the width of the machine. Inkjet technology. Among the various approaches for digital printing, inkjet has gained a very important place in the field of novel printing techniques. This technique is more like reprographic industry than textile printing, as it uses toners, inks and prints rather than dyes, pigments, printing paste and screens. In digital inkjet printing, print heads containing bags of fine nozzles fire fine droplets of individual colored inks onto the pre-treated fabric. The print design is created digitally and the ink droplets are mixed together on the fabric surface to create final color, so-called spot color. The print design concept is manipulated digitally and the setup time to produce short runs, sampling or proofing is dramatically decreased. Dyes are supplied in cartridges and are ready for immediate use. Compared to conventional method, consumption of energy and water is very low. The principle of inkjet printing is that the basic principle is directing tiny droplets of ink from a nozzle onto the printing substrate. General features of droplet formation is computer control of droplet position on substrate in response to high frequency digital electronic signals. It involves application of controlled pressure on the ink in the cartridge. As it flows through the printing nozzle, the ink is broken into droplets. The print head is one of the important parts of a digital printing machine. It can be said print head is the heart of the digital printer and software its brain. Print head determines the speed of production and overall print quality. Inkjet printers are classified as coarse resolution type, that is, it's based on valve control technology with resolution of up to 40 dpi. Fine resolution type, it has resolution up to 300 dpi. The significant features of this inkjet printers are the printing heads and nozzles. Numerous nozzles are useful for each color. These nozzles are 10 to 1000 mu in diameter. It can be subdivided into continuous stream printing, that is, drops are continuously produced and selectively printed. The second one is drop on demand. Here drops are produced when required and fires this onto the substrate. Now let's have a look at digital inks, or what is called as jet inks. Digital printing techniques make new demands on the colorants and formulations used. In screen printing, colors are applied in the form of high viscosity paste. Inkjet printing requires very thin ink formulations, and the colors or dyes used for inkjet printing should have small particle size, as oversized particles will block the jets. The average particle size of the ink must therefore be tiny compared to the nozzle orifices, and only then can smooth ink flow be guaranteed. The choice of auxiliary system is crucial for the stability of ink formulation. Basically, inkjet printing ink is classified into two types, that is water-based and solvent-based. Water constitutes the best vehicle for jet inks because of low viscosity, conductivity, order and cost, and since it's a good solvent for most dyes. Main disadvantage is evaporation. As water evaporates, salts and organic dyes may precipitate, increasing the probability that they will clog the nozzle. To reduce evaporation and prevent drying, ethylene glycol is normally added as humectants. The ink must be able to dry quickly after printing, but not during the printing process or while in flight. In order to produce well-defined print inks, main elements are viscosity and surface tension. Density must also be monitored. If viscosity is too high, droplets will not form. If too low the velocity, then it will not be uniform. If density is high, velocity will drop below operational level. Careful selection of thickening is necessary for correct viscosity. Substrate type determines the colorant selection. For textile fabrics of cotton, reactive dye, and for nylon or wool, acid dyes are used. A typical formulation will consist of a suitable solvent, colorant, thickener, bactericide, pH buffer, and sometimes an antioxidant. The physical property desired for inkjet printing can be summarized as purity, otherwise it will minimize clogging of print heads. The particle size, as pigments are coarse and insoluble in nature, they must be finely ground to obtain submicron size. The viscosity, low viscosity is necessary to allow easy flow through the nozzle. Dye must be high affinity for the substrate and good fastness. The jet, steady ejection of a homogeneous droplet reproducible in size, speed and direction. The functional properties required are machine compatibility, stable drop formation, no particle contamination and no nozzle blockage. The types of ink, they can be dye based and pigment based. The pigment based are insoluble particles applied as fine particulate dispersions. There are 4 types of dyestuffs available for commercial use as digital inks. The first one is fiber reactive inks. Cellulosics and protein fibers can be printed with fiber reactive inks. Reactive colors are bright, possesses good light fastness. Because the dye chemically reacts with the fiber, it exhibits excellent wash fastness as well. Fiber reactive inks require fabrics that is pre-treated for printing. Once printed, the fabric must be steamed and washed. Acid inks, these are anionic dyes. They are soluble and used for coloring nylon, silk, wool and leather. Acid inks give very bright colors and have good light fastness, making them suitable for outdoor flags. Acid dyes also react with the fibers, giving very good wash fastness. The fabric must be pre-treated with material to facilitate their fixation. Post-processing involves steaming and washing. Dispersed dyes, these have very low solubility in water but are solvent soluble. They are applied as finely dispersed aqueous inkjet inks to the media. They are limited to being used on polyester. The colors are bright but not as bright as acids and reactives. They sublime when heated to very high temperature. Once they become gaseous, they are absorbed by the polyester fibers. The dye condenses and becomes physically trapped inside, thus giving very good resistance to laundering. Excellent resistance of dispersed dyes to fading in sunlight make them appropriate for the toughest outdoor applications, including lawn furniture and upholstery. Pigment inks are the best choice for printing textiles. They tend to have excellent light fastness and can be used on all fibers. Fixation is very simple, involving only heat or UV curing. However, pigment inks must contain a binder to glue the pigments onto the fiber. The latest development is a pigment ink that can print on all types of fabric. Features of new pigment inkjet printing are: they are suitable for all fabrics, rich in color, brilliant with sharp outlines and are wash resistant. Next, let's see how the fabric should be selected. Selection of fabrics play an important role in print quality. For durability reasons, synthetic materials like nylon and polyester must be selected for outdoor usage like flags and banners. Other fabrics may be used for apparel and furnishings. Fabric pre-treatment for inkjet printing. In digital textile printing, pre-treatment and post-treatment are required to fix the colorants onto fabric and yield improved color appearance and durability. Pre-treatment chemicals cannot be included in the ink formulations because they affect the physical properties of the ink, making it unsuitable for jetting from the print head. Surface hairs lowers the print quality and must be removed by singeing. Impurities must be removed and the fabric is made absorbent and white by deicing, scouring and bleaching. The depth of color can be improved by mercerization process. Due to purity reasons, auxiliaries that help in dye fixation, color fastness and sharp prints are normally used in printing paste formulation cannot be added to inkjet inks. Hence, prior to printing, the fabric is coated or padded with chemicals necessary to fix the dyes specific to the ink being used, except pigment inks which require no pre-treatment. Chemical solutions range from simple to very complex. Simple formulations use soda ash, alginate or urea, while complex ones can be made of combinations of polymers, inorganic particulates, cationic agents and softeners. The pad liquor for reactive dye contains alginate for penetration, urea for better color depth and alkali for better fixation. For pre-treatment of wool and silk fabrics, an acid releasing agent such as ammonium sulfate and moisture absorbing agent such as urea should be included with some thickeners in the pre-treated solution which can be padded or coated on the fibers. A receiving layer on the surface of the fabric is then formed which can not only prevent the spreading of inkjets on the fabrics but can also improve the moisture regained from steaming, helping the fibers to swell and make the dye penetrate into the fiber more rapidly. For basic fabric pre-treatment, the solution includes anti-migrants. These are used to prevent migration of ink and prevent bleeding. Acids and alkalis are used to support reaction of ink. Urea and glycols to increase moisture content of fabric, giving high and even fixation of inks. The pre-treatment conditions. The samples are pre-treated with cationic substances or with a pre-treatment paste containing binder in addition to thickener. The fabrics are padded in the cationic agent for 3 minutes to gain a 90% pickup, then dried at room temperature. The pre-treated fabrics are then printed with a pigment ink by inkjet printer and fixed at 150 degrees centigrade for 5 minutes. Pigment printing needs no pre or post treatment, saving production time and reducing water pollution. Fixation and development of print. The post treatment of the digitally printed fabric is of supreme importance. Unless the print is properly fixed, color fastness would be a question mark. Based on the type of dye used in the ink formulation, fixation methods such as curing, chemical padding as in conventional printing could be adopted. For example, for reactive inks, cotton is steamed at around 100 degrees centigrade or for 8 to 10 minutes, or thermofixed at 140 to 150 degrees centigrade for 5 minutes, or steamed at high temperature for 2 to 4 minutes at 120 degrees centigrade and then washed. As with reactive dye, acid dyes are steamed in the fixation step. The temperature is the same, but the time is doubled. The pigments need only curing at 325 to 350 degree Fahrenheit for 30 to 90 seconds. For dispersed dyes, transfer of dye sublimation from paper to polyester is done at 380 to 410 degree Fahrenheit for 30 to 90 seconds. Digital printing has n number of advantages. Some of them are: they have attractive and complex designs, unlimited color and repeat size, clarity, fine line prints can be achieved with great precision. Since designers use Photoshop, Illustrator and digital photography, the new printing method acts as a tool in synchronization with such digital technologies. Designers are able to get photographs printed exactly as they are. HD print can be obtained, which is of great importance for designers these days. The sampling is also very easy. The short runs and quick delivery is another advantage. Fast and frequent design changes is possible. It is possible for designers to have last-minute changes to their designs. Small batches are as cost-effective as the large ones. Repeat orders are easy to process. It's a non-contact printing, hence image distortion is eliminated. There's no paste preparation and no waste as all color goes onto the fiber. It is a clean process as there's no preparation of equipment or colors since the software controls the printing processes. Customized and personalized goods at a competitive price. It's overall lower cost. Right quantity produced in right time, thus reducing environmental hazards caused by overproduction. It's eco-friendly with no liquid effluent, uses less hazardous chemicals and produces less wastage. Less water, energy and ink usage, hence the sustainability is improved. Sophisticated color matching and calibration technology producing accurate color matching. Digital printing combines design concepts like shadow shimmer, translucent, vibration, reflection, blurring, layering and superimposing to textile print designs. Applying the concepts creates new trends and design movements which can be avant-garde or very commercial. Independent designers are able to create custom textile prints with less effort and without having to depend so heavily on textile designers and large textile mills. Digital textile printing allows textiles to become more creative, innovative and commercially viable. Ability to print anything that you see on a computer screen is another advantage. Some of the disadvantages are banding is a problem created by the print head movement over the substrate. If head is not properly aligned or surface is uneven, a slight horizontal band or line of unprinted area occurs. A misfire occurs when the inkjet nozzle fails to send a drop of ink and results in a small unprinted area. Another problem is nozzle clogging. Pattern may lose some colors. Surface static charges on the surface may push or pull the ink particles away from the intended position, causing overspray or fogging. It requires a specially prepared and coated substrate for ink absorbency. Digital inks and toners are limited in capacity and carry high price tag. Textiles, unlike paper, vary in fiber content, weight, thickness, ink absorbency and yarn size. Let's see what is the future scope of this printing technology. The estimated potential of total printing today is around 30,000 million square meters and this is expected to grow at a rate of 1.5 to 2% per year. At the same time, digital printing, which currently has a share of around 1%, is expected to grow at a rate of 25%. This is a clear indicator of the importance of this new technology. The digital textile printing market is forecast to grow at an average annual growth rate of 20% in value terms between 2014 to 2019. It's estimated the total digital textile printing output will rise to 1.6 billion square meter annually by 2019. One area of expansion is customization, whereby a consumer is able to personalize a product by choosing a design. In order to improve speed and production, the one-pass method is gaining importance. Speed could also be increased by increasing the number of nozzles per color or per head. An increase in length of the print head will also help increase printing speed. Common applications include apparel, home furnishing, soft signage and flags. Development of more new applications for this technology will contribute to development and growth of this technology. Two application drivers for this include digital printing of automobile textiles, that is the car seat cover, interior carpet, seat belt, webbing. And the second one is deposition of functional fluids onto textiles using inkjet technology. It is a finishing process, as this process uses auxiliary chemicals to change the functionality of a textile substrate rather than simply creating colored design as in the regular digital printing. This finishing technique improves or add properties to the textile. The functional components that could be coated or deposited are quite varied. Example, antibiotics, moisture absorbents, water repellents, anti-static agents, UV absorbents, etc. So let's just summarize what we have dealt with. Digital printing is an innovative way to print anything on fabric, breaking the limitations faced with the conventional printing methods. Digital printing is a relatively new style in the field of textile printing and has immense potential to fulfill the demands of customers, designers, and processors. In order to harness its full potential, designers should be able to break free from their conventional mold in terms of creative freedom and think unconventional designs. Overall, the digital textile printing allows textiles to become more creative, innovative, and commercially viable. It's undoubtedly the most upcoming technology for value addition of textiles. With further advances in software, printer, and ink technologies, the inkjet printing of textiles will increase in importance in future. Hope you enjoyed the session. Have a great day.